said out of 13 parameters. Okay, as you said, pH is determined by using electrochemical process where the potential of H plus is measured by using glass elements. Okay, that instrument is pH meter. Madam will show that while you are going for hands-on and while you are going to determine the pH of the samples which you have brought. So roughly as Madam said, 4 samples have brought. For them you can determine. On your own you can determine. Each body can determine one sample. Okay, that is pH. EC, electrical conductivity. Electrical conductivity. That generally ions, they conduct certain electric current. So that is called ionic conductance. Each ion will have its own conductance. Chloride if you take sodium, any charged species will conduct electricity. These ionic conductances, when they are summed, they will produce the sum effect that is called electrical conductivity of the entire solution, nothing but water sample. So that is the sum of ionic conductances of all ions present in that water sample or that medium. Okay, that will be determined by using EC meter, electrical conductivity meter. Okay, where we will have actually anode and cathode compartment. Here we have dye. Yeah. So in the form of dye, we have anode and cathodic dyes. In between them, the solution comes in contact. So whatever the ionic conductances sum that is developed, that the instrument will give the output in microsiemens per centimeter unit. Microsiemens per centimeter. So that will be giving you electrical conductivity. From this, we will determine one dependent parameter, namely TDS, total dissolved solids. In fact, we can determine it by using gravimetric method also. But here as thumb rule, but not only here, in every water quality lab all over India, as a thumb rule, it is actually multiplied with 0.64. EC is multiplied with 0.64 to give TDS. Okay, in that way we will determine TDS. These are the 3 parameters which I said already. pH, EC, TDS, general parameters. They do not carry charge. Okay, general parameters. Next, if we go for cations, how many I said? 4. Sodium, potassium, calcium, magnesium. Among these 4, sodium and potassium, they are which family? Periodic table. Which group? They belong to which group of periodic table? Sodium and potassium, both of them come under one group. Alkali metals. They are alkali metals. Alkali metals, if you see the first group, 18 groups we have in periodic table, modern periodic table. First group, if you take hydrogen, lithium, sodium, potassium, rubidium, cesium, these elements will be there. So these are having actually high electropositivity or else low ionization potential. So to ionize them, just little bit energy is enough. So sodium and potassium, if you want to ionize, little bit flame will be enough. All these, they give characteristic flame in they give characteristic color in flame. That principle is utilized for sodium and potassium here to determine them. And the instrument name is flame photometer, where we are going to nebulize and spray the sample, and that will be burnt with normal LPG gas. Before that we will actually calibrate it with the known standards, and sodium will give yellow color, lithium will give I think lilac color. Okay, some lilac color will come. So these colors already they will be noted according to the calibration standards, and in your sample, suppose you have brought sample 1, in that sample 1, sodium and potassium, whatever be the concentrations, that concentrations will come directly in that flame photometer. So that is sodium and potassium. Both have been determined by using flame photometer instrument. Okay, we will get the results in ppm, parts per billion. Here the unit. pH does not have a unit, I said. Okay. EC will get it in microsiemens per centimeter. TDS again it is ppm. Sodium potassium again in ppm, parts per million. Okay. Now let us come to remaining 2 cations. Calcium and magnesium. These are used for determining total hardness, remember. Dependent parameter. Okay. So calcium and magnesium, for them we use titration here. Routine classical titrations. classical titrations. For magnesium, we use EDTA as titrant, and we will titrate by using EBT indicator. But here the problem is, this gives the sum of calcium and magnesium present together, because the EDTA complexes with both calcium and magnesium does not it does not selectively react with only one cation. That is the problem. So whatever the EDTA consumed will give the sum of calcium and magnesium being utilized. So to subtract one of them, we have one more titration, and that titration, that indicator is actually magnesium together will be given by EDTA titration. So we have to subtract to know one of the cation. For that we have one more titration where EDTA is still utilized, but the indicator this time it changes. Previously that was EBT, erythrochrome black tea, but this time we will use ammonium perchlorate. That is also called uroxide. That indicator selectively reacts with calcium, leaving behind magnesium. So in this case, we will whatever the EDTA consumed through burette is for only calcium. So now we have exclusive calcium amount or titer value in some VML. How to know magnesium then? Just subtraction as I already hinted you, it is subtraction. So if you sum, we have already calcium for magnesium together. Here we have second titration, calcium alone. If you subtract this value from there, whatever be the amount utilized for magnesium alone will come. In that way, and there will be some calculation. Okay, we have titration principles. N1V1 is equal to N2V2. Okay, so those titration in normality conditions, we will convert that into ppm again. Okay, so that is manual titration. So 4 cations completed. Sodium and potassium, plain photometer. Calcium and magnesium in titrations. Okay, let us come to anions. 3 physical parameters over 4 how many? 6 anionic parameters. Let me explain briefly about it. Hello. 6 parameters: carbonate, bicarbonate, and chloride. These 3 again they have been determined here, not only here, everywhere. Wherever the water analysis work is going on. Again, classical titrations. Okay. Carbonate will be present whenever pH value is greater than 8.3. pH value whenever it exceeds 8.3, then only carbonate will be present in our sample. Carbonate is titrated against, in burette we will take sulfuric acid in 0.02 normality. We will use methyl orange indicator, phenolphthalein indicator, and we will determine the carbonate. Okay. That will be explained. Okay. You can also do titration. Rakesh comes in. Okay. Then after carbonate, we will continue the process because the pH has changed to 8.3 at end point. When it exceeds, carbonate will be present. We will do analysis, titration, and that slowly, gradually decreases. Suppose if the pH of our sample is 8.7 comes down and reaches 8.3. At that juncture, we will get the end point. From there, we will continue bicarbonate. From there, in that same conical plus, we will continue bicarbonate by using methyl orange indicator. Okay, same titer will be there, the sulfuric acid, and in that way we will determine carbonate and bicarbonate in single titration, one by one. Okay, so 2 parameters over ppm. Everything will be listed. Carbon, all cations and anions they will be listed in, or they will be reported in ppm, parts per million. Nothing but milligram per liter. Remember. Milligram per liter. ppm is nothing but milligram per liter. Afterwards, chloride. Chloride is another anionic parameter, which as I said earlier, it is also from classical titration. Here, silver nitrate we will use. The titrant silver nitrate, AgNO3. That silver nitrate reacts with chloride Cl minus. Remember, chlorine is Cl2. Chloride is Cl minus. Reacts with chloride present and forms AgCl. Okay. That is precipitation reaction. Also comes under double displacement. Here we will determine silver nitrate, chloride by using silver nitrate titrant. Okay. In that way, we will determine chloride in ppms for silver by using silver nitrate. So these three anionic parameters have been determined by using classical titrations. So three anionic parameters have been completed. I am going very briefly. If I am given chance to explain the code, I need to take almost 3 to 4 hours to explain all this. So briefly I am explaining. Okay. There are a lot of principles, equations to come the final equation. So everything I am not explaining. The brief principle I am explaining. Okay. Afterwards, still 3 more anions are left. Still 3 more. Anybody in mind? Okay, I'll explain. Fluoride F minus. Okay, nitrate. You require, as Madam said yesterday also. Yesterday Madam called me and she said nitrate.
Yes.
NO3 minus, NO3 minus, and one more is sulfate, SO4 2 minus. Okay, now let me go for F minus. F minus is determined here by using ion meter. Ion meter uses ion selective electrodes to determine the potential of developed by that particular ion. For fluoride, we use lanthanum fluoride membrane containing ion selective electrode. That is called ISE, ion selective electrode. You can see that electrode. Okay, that is called probe also. So when you dip it directly, that shows the fluoride value in ppm. But before that, a lot of work will be there. We need to actually machines. They are machines just. We had to make them to learn. This is the known concentration from standard. This has a fellow. This has this much chloride. You learn. This second standard has this much chloride. You learn like that. We will make that instrument to learn. Okay. And there will be a calibration curve that will memorize in its integrated circuit. And when you put your sample after that all process, directly that shows fluoride in ppm, parts per million. Okay. Okay. So that is fluoride F minus by using ion meter. Ion meter uses one probe called ISE, ion selective electrode, which is particularly for fluoride. There is one electrode in with us. We can determine many ions in that way. Each ion, suppose ammonium can be determined. If you had to use specific probe, its probe. Ion meter is same, instrument is same. We had to use just like pen, there will be one probe. You have to dip it. If you have beaker, you have to dip it. This probe is specific for specific ion. Here we have fluoride probe, which uses lanthanum fluoride, LVIF. So from solution, we will dip the specific electrode. Here fluoride electrode or probe. We will directly get the value. Fluoride in ppm. They will show. Madam or sir, they have come up. They are assistant chemists. They have been analyzing many samples. We get here 5 district samples. This lab gets samples, groundwater samples from 5 districts. Okay, we have totally 5 regional laboratories in Andhra Pradesh. This is one regional laboratory as well as head office lab, controlling lab for entire area. Okay. Yeah, chloride. I think 2 anions left just. Nitrate has the ability. We can determine nitrate by using spectrophotometer. UV visible spectrophotometer is there. Among the explained instruments, that is somewhat costliest. Okay, that UV visible spectrophotometer determines the absorbance caused by NO3 minus, that is nitrate anion, at 220 nanometers. Okay, there also calibration will be everywhere. Instrument we had to make it to learn first. So we had to give known standards that will learn, and then when you put unknown sample, nothing but our sample, that will give the value. That's it. Okay, so there also nitrate will be determined like that. Okay, at 220 nanometer we will give the formula for 220 nanometer absorption. At that value, that gives absorption. That absorption causes some absorbance values in nanometers. Okay, that nanometer is 220 nanometer. Okay, and epsilon value will be there, absorption coefficient. That absorption coefficient will be recorded, and whatever the sample we have, unknown value. Already calibrated value absorbances will be there. That will be giving you the unknown nitrate value in ppms. That is graph x and y axis graph. X axis we will take concentration, y axis we will have absorbances. Okay, that instrument actually gives absorbance, not directly ppm. But internally there will be mechanism to convert that absorbance into ppm, nothing but concentration. ppm is nothing but milligram per liter here in this case. Okay. So like that we will determine nitrate, and one is left. I think one is left, anion. Carbonate, bicarbonate, chloride, titrations, over. Fluoride, ion meter, over. Nitrate, UV visible spectrophotometer, just now over. And one is sulfate. Sulfate, SO4 2 minus, sulfate. Sulfide is different. Okay, sulfate, this is sulfate, SO4 2 minus. Sulfate, again it is the precipitation principle, double displacement reaction, where barium chloride is used. Barium chloride reacts with sulfate present in our water sample and forms barium sulfate suspension. That suspension is measured by using Tyndall effect. Tyndall effect in electrochemistry, that comes Tyndall effect, means reflectance of sunlight by those colloidal or suspended particles. That principle, that Lamb principle is used, and the instrument which we use to determine the sulfate is nephaloturbidity meter. Nephaloturbidity meter. You can see every instrument which I have explained here now. Okay, nephaloturbidity meter. NEPHELO. Is that okay, girl? You are talking about nephlo is new word for you. That is routine spelling anti like that. Nephaloturbidity meter. So that nephaloturbidity meter is used to determine the sulfate, and the principle is formation of barium sulfate suspension. Okay, barium sulfate suspension will be formed, and that will be kept in cell, and the light that is Tyndall, using Tyndall effect, whatever the in 90 degree, that whatever it is reflected, that amount will be taken, and that will be converted into concentration values. Again, there also calibrations will be there. Okay, so we will get directly the sulfate value in ppm, parts per million, nothing but milligram per liter. Okay, that's it. So these are 6 anions. First 3 general parameters, 4 cationic parameters, 6 anionic parameters. From these we have certain dependent parameters: total hardness, RSC, residual sodium carbonate, SCR, sodium absorption ratio, percentage of sodium, magnesium absorption ratio, like this. These are dependent parameters. One can do in Excel by giving formula, because already we have known values. These, upon them we will have certain formula. That formula utilizes these ions concentrations and gives that particular dependent parameter. Okay, like that we will do. Okay, this has been done here. Okay, you can see by visiting the lab. You can go to madam. Okay, find it out. You can come afterwards while leaving. You can know whatever be the doubt you got during that hands-on. You can ask me.